Hey, welcome back. Today I'm going to be going over this SAT question, and once again, thanks to Aniko.ai for providing this specific question in their free resources tab. But before I get started, please give this a try yourself. Okay, so here we have the following expression given, and it can be written in this form where a, b, c, and d are integers, which choice is the maximum possible value of k. So right away, we know our end goal is to maximize that value of k. Okay, so now how do we actually get to that? Well, you'll notice that they give us another form of this expression, right? A factored form, where if you multiply everything out here, you technically get this, right? So let's expand this out first, just to see what we get, right? If we expand this, right, that means you FOIL, you multiply everything out, you get AC x to the 12th plus AD x to the 6th plus BC x to the 6th plus BD, right? That's what you get when you simplify everything. Well, we're trying to find the maximum possible value of k, and we know that k, right, in this other expression, the given expression, we know that k is x to the 6th, right? It's the x to the 6th term. What are the x to the 6th terms here? Well, you'll notice that you can rewrite this as AD plus BC times x to the 6th, right? And if you follow that logic, well, if this is x to the 6th here, right? If k is x to the 6th here, then that means k has to equal AD plus BC, right? Because we're matching coefficients, right? Because technically, again, right, this expression here is equivalent to this one, right? So we've determined that k equals that. Now, well, how do we actually find the maximum k, right? There's a lot of constants here. What are those constants actually going to be? Well, what is a? You'll notice that here, if you go back to the given expression, that a, right, times c, right, a times c equals 20. So I'll write that. You have a times c equals 20. And likewise, b times d equals 45. Why is this useful? Well, in the first place, they tell us that all of these are integers, right? All these constants are integers. Well, if a, b, c, and d are integers, right? Well, that means if you have, for example, a times c equals 20, that each of these have to be a multiple of 20, right? Sorry, or not a multiple, a factor of 20, right? For example, like 4 times 5, right? That equals 20. 1 times 20, that equals 20. 10 times 2, right? Those 10 and 2, those are factors, right? So we know that a and c here have to be factors of 20, right? Because they're both integers. So what are the different factors of 20? Well, I just listed them out, right? We have 1, 2, 4, 5, 10, and 20. Those are the different factors of 20. Same logic. What are the factors of 45? Well, you have 1, 3, 5, 9, 15, and 45, right? So those are the factors of both of those numbers. And actually, what I'll do is use a different color for this one, so it's easier. But those are the different factors, right? So now you'll notice that A and C are factors of 20, whereas B and D are both factors of 45. Go back to this original expression. We're trying to maximize the value of K. Well, that means A times D. You can actually rewrite this entire thing as a factor of 20, right? Because A is a factor of 20. So you have a factor of 20 times D, which is a factor of 45, plus a factor, I'm going to say corresponding factor, right? Because remember, you're still multiplying out. You're still multiplying out to 20 and 45. So then plus b, which is a factor of 45, times the corresponding, sorry for the handwriting, but that says corresponding factor of 20, right? So this is effectively what we're trying to maximize. How do we actually maximize it? Well, if you look at the answer choices, right? These are our answer choices for the maximum possible values. You'll notice that the biggest one is 901. Again, we don't know if that's the right answer, but is there any way we can get close to that number or that number itself through this specific expression here? Well, you'll realize that a factor of 20 times a factor of 45. Well, if you're trying to find the maximum possible value, we want the largest possible a times d, right, or b times c, right? We want the largest possible product of the factor of 20 times factor of 45. Well, that's simply 20 times 45, right? Because 20 times 45 is bigger than like 10 times 45 or 5 times 45, right? Or 4 times 45. Similarly, right, 20 times 45 is bigger than 20 times 15 or 20 times 9 or 20 times 5, right? So we know that 20 times 45 is going to give us the biggest product, right? So we have 20 times 45, right? Plus, this is where the corresponding part comes in. Well, we know that A times C has to be 20, right? A times C equals 20. Well, if A is 20, then that means C has to be 1, right? Likewise, if D is 45, well, we know B times D is 45, so therefore B also has to be 1, right? And you'll notice that this is 900 plus 1, which gives us 901, right? That's our maximum possible value, so therefore, indeed, answer choice D is actually the correct answer here. Now, what are the key things to take away for this problem? Well, first of all, right, determine what K can be, right? What actually is K, right? In this problem, we figured that K is AD plus BC. Once we figure that out, we realize that A, B, C, and D, well, you can actually give meaning to those numbers because you'll realize that those are factors of 20 and 45. Right? Combined with the fact that A times C equals 20, B times C equals 45, you basically list out all the factors of both of those numbers, and you also realize that to find the maximum possible value, you want the maximum possible product of one of these terms, right? In that case, that was 45 times 20. And just follow that, right? Follow the algebra, make sure you list out the corresponding factors, right? Using A times C equals 20 and B times C equals 45, and I'll give you to your final answer. So basically optimize, right? Optimize as much as you can. If you want, you can experiment, right? I picked 20 and 45 as A and D, but you can always experiment, try different numbers, right? But once again, this is an optimization problem, right? Your goal is to run experiments, right? Plug in numbers and see which one gives you the biggest answer. Most of the time, right? 90% of the time, if you multiply the two biggest numbers from each pair, it will give you the maximum value. So that's how you do this question. I hope this made sense. If it didn't, please leave any questions you have down in the comments. But thanks for watching, and I'll see you next time.